In this video, we're going to explore a more visually engaging way to use Python called Turtle Graphics. So Turtle Graphics is a Python library that lets us control a small on-screen turtle which can draw shapes and patterns as it moves. So in this video, we'll look at how to get started with Turtle Graphics, learn a bit about its basic drawing commands, and see the various options available to change how the tool looks and behaves. So let's get started. Before we write a full Turtle Graphics program, let's first see Turtle Graphics in use directly in the interactive Python shell. So we'll open up a PowerShell window here. We'll just say Python, which gives us the interactive interpreter. Here in the Python shell, we can run commands one line at a time to see the results immediately. Now, before we can use Turtle Graphics in Python, we have to first import it. It's part of Python's standard library, so no new installation needed. We just say import turtle. And this gives us access to all the basic turtle commands. To start drawing, all we need to do is say turtle.forward. And then give it some distance to move forward. It's measured in pixels. So if I say turtle.forward 100, and when we run this, a new window opens called the canvas. And if I were quick enough, we could see the arrow moving slowly across the middle of the screen, drawing a line as it goes. But with the screen still up, let's try some more commands. So I can say turtle.left 90, and that's the number of degrees to turn to the left. I can say turtle.forward 50. The turtle, or the arrow if you prefer, turns left by 90 degrees and then moves forward by 50 pixels, drawing a line upward on the canvas as it goes. We can also turn right and move backwards, so turtle.right, say some other value, 45 degrees, and turtle.backward by 70 pixels. And notice as we enter more and more commands, the image on the canvas slowly grows and grows, creating something complex like the drawing of a house if you wished, through many small actions or lines. Let's go over a few other useful turtle commands before we move into making a fully fledged program. First off, there are times when drawing where you want to relocate the pen without drawing a line as it goes. So to move the pen without drawing, we can use the pen up and pen down commands. So turtle.pen up doesn't change how it appears, but now if we move that turtle, we could say turtle.forward by 150. And notice it moved somewhere else on the screen but didn't create a line as it went, and now that arrow is off on its own without a connecting line. We can then put the pen down and start drawing in this new location. So turtle.pen down, all one word, and then turtle.forward, let's go forward 50 again. We can also change the color and shape of the pen, so I can say turtle.pen color is orange. So to change the color of the pen, you can use turtle.pen color, and then as an argument, you give it a string representing a color. You can use predefined color constants, and Turtle Graphics does have a lot of color constants that it recognizes. These are just English words of colors like red, blue, green, maroon, aquamarine, things like that. And if we pass that into the pen color function, then it changes the color of our pen. And if you look close, you can see the outline of the turtle has changed. And if we move forward, we can draw a line here. So I can say turtle.forward 20. That's a bad example. Do another one with a long line, and we can see it's drawn an orange line there. So you can use color constants just as English words, or if you want to be more precise for your colors, you can use hex codes to represent them. So I can say turtle.pen color hashtag 57FF33. So a bunch of red, a lot of green, and a bit of blue. And if we run that, we can see the turtle's changed into a sort of green shade. And if I go, let's say, turtle.left 142 degrees, some random value, and turtle.forward 190 pixels, we can see it draws a green line as it goes. If you want to set the canvas background color, you can use the command bg color. So we can say turtle.bg color, and then 000000, which should be an all black background, and we can see our background is black. Now, with a black background, all of our black lines have disappeared, but you can still see the colored lines that we created at the end there. It's important to notice also that when we use the word color, so in pen color or background color, there's another one called fill color, the word color is spelt without a U. This is fairly consistent within programming in any language. We generally speaking always use the Americanized spelling of things. Your variables are free to be however you want, but for the built-in functions, they're written without the U. We can also change the shape of the pen itself. This doesn't actually affect the drawing at all, but for personal preference, there's a few predefined shapes we can use instead of an arrow. So I can say, for example, turtle.shape, and then the word turtle. And now notice, instead of an arrow drawing our lines, it looks like a turtle that's drawing our lines. I say turtle.right 270, can make that turtle spin around. We can also make the turtle itself invisible by saying turtle.shape is blank. And then if we say turtle.forward 200, the line just appears on its own without some sort of leading shape drawing it. Other options here include circle, square, triangle, and classic. And again, this doesn't affect the drawing itself, it's just the shape of the pen that's doing the drawing. Now, if you want to clear everything, so if you want to pick up the Etch-a-Sketch and shake it, then you can just type turtle.reset, and everything goes back to the beginning. This clears the canvas and resets the turtle. As you can see, it didn't reset the background color, but if I say turtle.shape is a turtle again, if I say turtle.bg color is white again, then we can see there's our turtle standing in the middle and no other lines have been drawn on our canvas. Okay, now let's put all this together and write a script that makes a turtle graphics drawing. So let's go back to VS Code and make a new file here. I'll call this drawing1.py. And now let's put some turtle code inside this file. So first things first, we have to say import turtle so that we can use the turtle. And then let's set up our pen. So we can say set up the turtle and do things like turtle.shape is going to be a turtle because I like seeing a turtle walk around on the screen. We'll say turtle.color and we'll make a random color here. So 45 AF8C. So this is something that's a little bit of a green pen here. And we can also change the thickness of our line. So we can say turtle.pen size, which is by default 1. So if we want to make that a little bigger, we can say pen size 3. And this makes thicker lines. Now, once we've got everything ready to go, we can then say, let's draw a shape. Let's also set the background color, actually. Turtle.bg color is, I like a black canvas. And now we're ready to draw a shape. So let's draw a shape. And to do that, we just start walking. So let's first make a variable for our shape. We'll say the size of our shape is going to be 100 pixels. So we're going to have consistent sized edges here. Since we're starting in the middle of the screen, we'll go half of that in the first step. So we'll say turtle.forward size over 2. So if size is 100, size divided by 2 is 50. We're going to move to the right by 50 pixels, and then we'll just turn. So turtle.left 120 degrees, and then turtle.forward again by the amount size. We'll take a full length that time, and we'll do that again. Actually, like this to copy these two lines and paste them again. And then we want to turn left one more time, turtle.left 120, and then move forward. If we're drawing a triangle here, as you might have guessed, the last size there will be size over 2 as well. So that should make a turtle walk around on the screen and draw some shape. But if we want to see the drawing once it's done, then we'll also need to include the following line at the end of our program. And this keeps the window open. So we'll say turtle.exit on click. So what that means is don't exit right away. Wait until someone clicks the X on the window, the closing box on the window, in order to exit the entire program. Otherwise, Turtle will do all this drawing and then just finish the program, shutting down the drawing before we really get a chance to see it. But let's try this and see what we get. So Python drawing1.py. I'm trying to be quick here. And if we run this code line by line, our turtle follows all the commands in our script, and we end up with a drawing of a simple triangle. The nice thing about doing it this way in a script, as opposed to in the interactive mode, is that if we make a small mistake in our drawing, if it's just a little bit off, then we can modify things slightly and run it again without having to type all the different commands. Now, one word of warning, let's close this. One word of warning is to be careful not to name your local file turtle.py. So I've called mine drawing1.py, and that was fine. But if you called it turtle.py, and I'll demonstrate this, then doing so will hide the turtle graphics library. So when you go to import it at the top here, Python says it's overriding the standard library module turtle. And if we try to run our code, so that'd be, if I just say python turtle.py, we get an error. Attribute error, partially initialized module turtle has no attribute shape, most likely due to a circular import. So this first part probably doesn't mean a lot to you in terms of descriptive errors, but most likely due to a circular import kind of gives you a pretty good clue. So a circular import is a file that's trying to import itself. So here where it says import turtle, Python sees a local file called turtle and tries to import that here. And then when we try to say turtle.shape, turtle.color and all those don't exist because we haven't defined them in our local file. We were hoping the standard library turtle had those defined, but since we blocked that import by naming our file turtle, we can't access any of those functions. So the simple way to solve this is just to never call your file the name of the thing that you're importing. So we'll call this drawing1.py. And when we run our code, no issues. Now, next up, let's expand this drawing with a bit of randomness, just to make it a bit more interesting. So I'm just going to, we don't need this cache anymore. Goodbye. And I'm going to copy drawing1 into a new file. We'll call it drawing2. So if we want to add some randomness into our code, the first thing we need to do is import random. It gives us access to all the random library functions. Then we can use the random library to make the shape appear, let's say, at a random location on the screen. The way we can do this is if before we start drawing, we lift our pen and put it at a random location, and then set it down, then whatever we draw will show up at that random location. So before we draw a shape, let's relocate the pen randomly. So we'll say, first off, turtle.penUp means we're not going to draw when we move. Now our turtle starts facing to the right in the center of the screen. So let's rotate it in a random amount, so in a random direction. So we'll say turtle.left by some amount. So this is random.randint between 0 and 360. 360 is a full circle, so any value in that range is going to be some random direction. We're going to point in that random direction, and then we'll say turtle.forward by some random distance, random.randint again. We'll say at minimum, move 10 pixels, and at maximum, 200 pixels. Then we say turtle.pen down, and we're ready to draw. So we've lifted our pen up, spun it in a random direction, jumped forward by a bunch, and then set our pen down, and then we just go back to drawing the stuff as we were drawing before. So let's save and test this out. So Python drawing2.py. We run our code. A separate window pops up on the other screen here. With our triangle, move to a random location on the screen at a slightly random angle, and then we draw our triangle. If we like, we can make it a random size as well. So we can say, instead of size equals 100, we could say size equals random.randint between, let's say, 50 and 400. And now since we're using that size variable everywhere where we move forward while we're drawing, they'll all have that new larger size. Let's save and run this. Code's still open. We have to close it first, and then we can rerun our code. So then we call drawing again. It pops up on another screen here, jumps to a random spot, and draws, in this case, a smaller triangle. If we run it again, we'll get a different size triangle in a different location. And just to demonstrate, I want to also show we can make filled shapes in Python. So instead of just drawing lines, we can say draw these lines and then fill the center of the line that we created. To do that, we have to tell our turtle where this shape begins and ends, using the commands begin fill and end fill. So if we put all of our movement commands between a turtle.begin fill and a turtle.end fill, save and run our code. Then our turtle starts drawing, and when it's done, the shape that it draws fills in. Now in this case it makes sense because our turtle started and ended at the same location. We made sure to draw a triangle that landed back where it started. If you don't stop where you started, that is to say if your begin fill starts in one location and your end fill, your turtle's in a completely different location, turtle will just draw a line between those 2 points and fill in whatever shape you've created. They don't have to be standard shapes like triangles, these can be abstract shapes as well. So now instead of just getting a triangle in the middle of the screen, each time we run the program we get a triangle in a random location with a different size and a colored in center. Now, as we learn more about programming in Python, we'll return to turtle graphics to make more dynamic drawings, like the scene with the house and the flowers that we saw in the first chapter, for instance. This is also a good time to go back and review the code that drew that house demo to see how much more of it makes sense now. Beyond this, play around with Python expressions and turtle graphics, try experimenting with different expressions, colors, and movements, and challenge yourself to draw something that you're interested in. And that's it for this video. Don't forget to blink, and I'll talk at you in the next one.